we're going to be reviewing some things that you learned earlier this school year about rational exponents. We're going to start with switching things that are in exponential form with rational exponents, meaning the exponents are fractions, and putting them into radical form, meaning they look more like what you see down here where you have some sort of root symbol. So the key thing to remember here with these 4 problems that we're going to look at is we're just switching from one format to another. So you're not doing any calculations, you're just putting things in different places. If you have a fraction exponent expression like this, we're going to switch it into radical form like this. Notice that the top number of the fraction exponent becomes the exponent on the outside, and the bottom number of the fraction exponent becomes the type of root. So for this first one, we have n to the 4 over 5. N, your base is going to be inside your root. That top number 4 of your fraction becomes the exponent on the outside. The bottom number 5 becomes your type of root. It's a 5th root. Once you've done that rearranging, you're all done. So here in the blue is your final answer. Same idea if you have something with parentheses already. Your base, whatever the exponent is being given to, 5e, goes inside the root. 5 is going to be our exponent on the outside. This is the top number of the fraction. And the bottom number here is 2. You could write a 2 here if you wanted to. However, a 2 root is a square root, and square roots, we don't need to have a number there. It was called the index. So having a 2 there wouldn't be incorrect. It would just look weird. This right here in the blue is your best final answer. So again, if you don't see a root there, it's a hidden square root, hidden root 2. Now let's go the other direction. These are starting with radicals. We want to switch them to exponential form, meaning we want them to look like something with a base and some sort of fraction exponent as our final answer. So our base here, whatever's inside the root, is just x. And we have something hidden here. Normally we see parentheses and an exponent on the outside. We don't see an exponent on the outside as a hidden 1. We're now kind of going the opposite direction of what we just did. In order to change this radical into a fraction exponent, the number on the outside exponent becomes the top number of the fraction. The type of root or index becomes the bottom number of the fraction. So since we have a hidden 1 on the outside, 1 is the top number of my fraction exponent, and the 4 is my index or type of root. 4 will be the bottom number. So this becomes x to the 1 over 4. Same idea here. When you have a number and a variable together as your base, make sure you put them in parentheses. I'm going to make that look a little bit prettier. So I'm going to put 4x inside the parentheses. For my fraction exponent, that exponent number on the outside 2 becomes the top number of the fraction, and the type of root or index becomes the bottom number of the fraction. So that turns into 4x all raised to the 2/3 power. The other 3 problems we're going to look at in this video are just involving simplifying exponent expressions, just going back through your exponent rules we did earlier in the year. So the instructions here just say to simplify. This first one uses our product rule. We are going to multiply our coefficients. 4 times 4 is 16. And then your product rule, if you think back to earlier in the year, if we multiply 2 things with the same base, we added the exponents. So any like exponents I'm going to add together. I have m's here, so I'm going to add 1/2 plus 2, because I have m to the 1/2 and m squared. And then I only have one thing with a base n, so it's not going to change, it's going to stay the same. Final answers, we want to see all of our exponents written as either integers like 1, 2, 3, etc., or as improper fractions. We don't want mixed numbers, we don't want decimals. So everything here is good to go except for this m exponent. The 16 coefficient is part of our final answer. If I add 1/2 plus 2, I get 2.5, which is the same as 5 over 2. You can use a calculator or Desmos to help you out with that. And then n to the 1/2 stays the same. So this right here is my best final answer. If you had something multiple choice like your final exam will be, they might switch the order of the m part and the n part, and that's fine as long as all the exponents are correct. The next one involves our quotient rule. So thinking back to earlier in the year, if I have a fraction or division, the way I simplify that is I subtract the exponent, top exponent minus bottom exponent. So most of this stays the same, sort of like in this first one. There's only one y part in this whole problem, so y squared stays on the top. There's only one coefficient in this whole problem, so coefficient 2 or divided by 2 stays on the bottom. What we need to take care of is the x's. We're going to do top exponent minus bottom exponent. So 4 over 3 minus 1 over 4. You are welcome to do that exponent subtraction in your calculator, or you can do it by hand. If you're doing things by hand, you have to find a common denominator. 4 over 3 becomes 16 over 12. 1 over 4 becomes 3 over 12. So when we subtract those, 16 over 12 minus 3 over 12, I get 13 over 12 for my x exponent. So my final answer here is going to be x to the 13 over 12. The y squared stays the same. The divided by 2 stays the same. Nothing too crazy there. For the last one, we are going to take care of in this video. We are going to be using our power of a power rule. So thinking back to earlier in the school year, if I have an exponent on the inside and an exponent on the outside, I distribute or multiply those exponents together. So it becomes x to the a times b. And if I have more than one thing inside the parentheses, that outside exponent gets distributed to everything inside. So what I'm thinking is u to the 3 over 4 times 4 over 3. And then same idea with v. v to the 5 over 3 times 4 over 3. When you're multiplying fractions, you can use a calculator as always. If you're doing things by hand, you go straight across the top, straight across the bottom. So if I multiply 3 times 4, I get 12. If I multiply 4 times 3, I get 12. 12 divided by 12 is 1. So this becomes u to the 1. For my v's, 5 times 4 is 20. 3 times 3 is 9. What I have there in blue is technically correct, but it would look kind of weird as a final answer. Remember that when we have an exponent 1, we don't have to write it, it's implied. So the best final answer, like what you would see if you had a multiple choice option here, would be u, just u, and then v to the 20 over 9. This means the same as u to the 1, v to the 20 over 9. It's just we don't have to write that u1 exponent. For this homework assignment, there'll be one more video where I show you a few more things, but that's it for this video. Have a great day.